Hello everybody and welcome back. Root Beer here with another math contest, the 2011 MMC or Manitoba Math Contest. This is a nice little contest put out by the University of Manitoba. As I recall, it's held on the exact same day as the Pascal, Cayley, and Fermat. It's for grade 12 students, and it's an excellent contest to try. It's excellent practice for other things, like, for example, the grade 12 Euclid, written later in the year. So it's a fantastic contest. So we're going to go through another one of 2011. If you'd like a copy of this contest, and I do encourage you guys to try them before watching my videos, just so you get a sense of where you're at, what you need to work on, how far you could actually make it in one of these. Click the link in the description and you will get a copy of this contest. If you click the second link, it'll take you to their website and you can try all the Manitoba, all the MMCs. Not just the 2011 that I'll be going through. So I've got my pen ready. Hopefully you've got yours. So let's take a look. We're just going to do question number 1 in this video. Do notice two things I like to mention. Usually I encourage you guys to read the instructions. 2 things to mention. 2 hours long. So from 9 to 11 there. And calculators not allowed. Okay, so don't be reaching for your calculator as you practice this one. But with those two caveats, those 2 notes in mind, let's take a look here at question 1. 1A. A square has diagonal 10 centimeters long. Find the area of the square. Okay. This actually isn't too bad, and some of you out there might be able to do this one in your head. A square has diagonal of 10 centimeters, so if we just imagine the diagonal in our head, if the square has side length, say x, and then the diagonal is root 2 of x. What's the area of a square? Oh, if its side length is x, it'll be x squared. So we want x squared. We know root 2x is 10. Square both sides. 10 squared is 2x squared. So 10 squared over 250 is x squared, the area of the square. But we want to write that up. We don't want to just give them, oh, our answer is 50. That's not going to get us full marks. So we got to write this all down. And not everyone out there, of course, can be doing this in their head. But it's a worthy exercise to see, can I do a question 1 in my head? So I might draw myself a picture. And I might just write up exactly what I've said there. Let x be the side length of the square. So the area is x squared. Well, the diagonal is the only thing they gave me. We have a 10 here, 10 centimeters particularly. I never know whether or not to be including my units when it's a written question, but you should probably try. You might say something like, by Pythagoras, or by Pythagoras' theorem, that sort of thing. X squared plus x squared is 10 squared centimeters squared, or 10 square centimeters. No, 10 square centimeters would just be 10 centimeters squared. So 10 squared square centimeters. Okay. Well, really, that's just 2x squared is 100 centimeters squared. X squared is 100 centimeters squared all over 2. 50 square centimeters. So the area is 50 centimeters squared. And not a whole lot to work with there, but that's all we had to do. Question 1 there. Well, 1A. We do have 1B left to do. So we'll take a look at that as soon as I finish making my 50s, or my 5 look like a 5. Alright, 1B here. ABCD is a square. AB and CD are increased by 10%, while BC and DA are decreased in length by 10%. Increased 10%, decreased 10%. What percent does the area change? Okay. So, one thing to note, you can, if you're quite good at these contests, you can think, oh, questions 1, 2, 3, I'm just going to rush through those, they're a breeze. It happens less on, say, this contest because you have to explain everything. More happens on, say, the Euclid, where there are light bulb questions, you just need your final answer. Were this a light bulb on, say, the 2011 Euclid, You might say, well, the one thing increases by 10, the other decreases by 10, they cancel out, just 0. Put 0 in the box, don't think about it. We often don't go back and review our answers to question 1 and question 2 just because we think, well, they're easy. And you can very easily rush and do sort of the same thing and say 1b, well, they're increased by 10, decreased by 10, going to cancel out. But actually something else is going on. And thankfully they ask us to write everything out, so we do have to explain a little bit of what's going on, and we're going to see what exactly is happening and why it is not just a net change of nothing. Okay. So, increased by a certain amount, decreased by a certain amount, or a certain percent, these can be turned into mathematical multiplication expressions. So I might say increase by x percent is the same as multiplying by 1 plus x over 100. Increase by 10%, that's the same as multiplying by 1.1, 1 1/10. Now, for most of you, this might be this could very well be sort of obvious, and I don't think it really bears writing out. But if you want to explain where everything's coming from, so in decreasing by this amount, we would not divide. I keep wanting to write divide. We would multiply by 1 minus x over 100. So decreasing by 10% is the same as just being 90% of the whole thing. So increase by 10% is multiplied by 1.1. Decrease by 10% is multiplied by 0.9. So the new area is, well, it's 1.1 times AB. I can write that a little better. I don't need brackets around 1.1. So it's 1.1 times AB times 0.9 AD, or BC, however you want to say it. So this is 1.1 times 0.9, or 0.99 ABAD, but this is 0.99 times the original square. Okay. So I double check. You sort of do the math in your head, but this is really 11 times 9 is what's really going on, and then you make sure the decimal's in the right place. Okay. So it's 0.99 times the original square's area if you need to. For reference, where I'm getting these lengths from, we get A, B, C, D. Okay, so we have AB times AD. That should be the area here. You could even, since they told you it's a square, you could even step in and say something like, well, let x be the side length there, and then you'll get 1.1x times 0.9x is 0.99x squared. Doesn't really matter, but. So to get the new area from the original area, we multiply by 0.99. And I think they wanted percent change. By what percent does the area change? Multiplying by 0.99, well, that's just 1. It's less than 1, so it's 1 minus x over 100. So then we could rearrange, and 1 minus 0.99 is x over 100. But this is just 1/100th. Not hard to see x is 1. So the area decreases by 1% overall. Or you could say something a little fancier, it doesn't particularly matter. But we could also sort of picture this if I increase AB and DC by 10%, we're going to have sort of 0.1 extra of this x over here. But if we decrease AD, well, then we're sort of almost short a little bit. We're short by 0.1x is here, and 0.9x is here. And so we're short by a little bit. And what are we sort of short by? Well, we're just short by a 0.1x, because these two areas here are the same. Are they? No, something. No, I thought I could explain this with a picture, and I seem to be off ever. Oh, no. Okay, so so this blue area and this blue area are the same. So it's still x squared, but minus the filled-in green area, or the special area that I've got here. So really, overall, we've subtracted off the 0.1, so the 0.01. So that's pictorially what we've done, but I prefer the explanation here with the calculations and the percents. But there we go. That's question number 1. Fantastic way to start things off. In the next video, we're going to take a look at question number 2. Thank you guys for watching, and as always, I'll see you in the next video, whatever it happens to be.